What's up everyone? Today we're going to be going over a fun little project that you might want to do called Link Aggregation. And what that allows is primarily link redundancy. So you have multiple connections to a switch that in the event one fails, the other takes over. So there's no service interruption, or basically next to no interruption. However, normally when you do that, you get hit with spanning tree. And what spanning tree is going to do is, let's say you have 3 links from switch 1 to switch 2. 2 of those links are going to be closed so as to prevent a loop from forming. Link aggregation gets around that by creating let's just say a virtual port that takes all the physical ports, bundles them into one logical port, and that is the one that participates in spanning tree. The other ones do not. So let's go ahead and first look at a topology so we can examine what that might look like. And then I'm going to go into my lab, my hardware lab, and we're going to go ahead and commit that to some physical route switches. All right, let's go ahead and first come on over to Packet Tracer here, since this is a reasonable facsimile of my home network. So right now, my home network has 2 links between all switches. So switch 0 has 2 to switch 1, 2 to switch 2. Switch 1 and switch 2 also have 2 links between each other. If I were to snip G1022, what would happen is G1021 still maintains its connection. PC1, PC2 can still reach PC5. No problem. And they'd still be able to get to R1 or R2 depending on what the FHRP is doing at the time, or they can even reach the internet. They won't notice a thing. However, there is a side benefit to doing this. So let's say there is a NAS on switch 0, alright? PC1 is doing a backup, and it is using full line speed, alright? So this is a gigabit, that's a gigabit, and then going down here is a gigabit. So that line, so between switch 1 and switch 2, is saturated. Any traffic that tries to reach switch 0 from switch 1 is going to have little to no bandwidth to do so. So those connections will be slow. Likewise, any connection from switch 1 to switch 0 that wants to reach the internet is also going to be very slow because PC1 going to the NAS is saturating that connection. Well, if we have link aggregation set up, what ends up happening is that PC1 backup is going to go over G1021 to the NAS, but then PC2 is going to hit this switch, and then switch 1 is going to be like, hey, this line's like really busy, so I'm going to send you over this one. And then PC2 has absolutely no bandwidth hit whatsoever. And that's essentially link aggregation in a nutshell. Now what I'm going to do is I'm going to go ahead and just show a quick configuration on my switches that I have here. We're not going to use Packet Tracer for that. Show you what it looks like. And let's go ahead and fire them up. Let's start with my home switch here. So first things first, we're going to go into switch status. All right. Interface range. So let's just do G1, 0, 25 through 26. That's going to switch 1. Channel group 1 mode active. Actually, let me delete that real quick. All right, let me explain what I'm doing with this command here. So what we want to do is we want to get into the interfaces we want to bond together. Ideally, these would be interfaces physically next to each other. Just makes it easier to deal with. So channel group 1 is going to bundle 25 and 26 on this switch. And now we need to tell it what mode it's going to act in. So we have 3 options. We have LACP, PAGP, and static ether channel. If we are an all Cisco house and we anticipate being Cisco only, you can use PAGP. If you have cross-vendor equipment in your topology, say you have a Unify switch here, an Aruba switch there, and a bunch of Ciscos, you probably want to use LACP, so active and passive. All right, so I'm going to go ahead and do passive, mode passive. All right, then we're going to go ahead and configure the virtual port that was just configured. And then we're going to do switch port trunk allowed VLAN 5, 10, 15, 20. So that's what's on this switch. Switch port mode trunk. Hold on. There we go. Don't know why it was doing that. Now it's a trunk. That was weird. All right. Let's go ahead and see. Make sure I put in the commands that I need. I don't think I did. But we're done in PO1. Now let's do the same thing for PO2. Interface range G1027 through 28. Channel group 2, since this is going to switch 2, we'll make this one active. All right. No shut. All right, and we are done here for a moment. Interface PO2 switch port inc dot switch port trunk switch port trunk allowed VLAN 5, 10, 15, 20. Switch port mode trunk. All right, now let's move on to switch 2. So what I want you to remember is that for channel group 1, between switch 1 and switch 0, we set up passive. And I'll explain what that does in just a moment. Interface range. First, let's confirm our interfaces. Do show int status. I highly encourage you go through your interfaces and label them. Makes your life easier. Interface G021 through 22. Oh. Range. Now, channel group 1 mode. Now, on the other side of switch 1 at switch 0, it's passive. So we're going to do active. No shut. Interface PO1. Switch port trunk inc dot. All right, so that one's already doing encapsulation. Switch port trunk allowed VLAN. And you can see it's doing the negotiations here, forming the ether channel. Switch port trunk 5, 10, 15, 20. Switch port mode trunk. Exit interface range G023 through 24. Channel. Now this one's going to be between switch 1 and switch 2. We'll make that the third channel group. Channel group 3, mode active. Interface PO3, switch port trunk loud VLAN 5, 10, 15, 20. Switch port mode trunk. Do show in status. All right, so PO3 hasn't done anything yet. Let's get into our final switch, lab switch 2. Switch interface do show int status interface range G0 21 through 22 switch port trunk allowed VLAN 5 10 15 20 switch port mode. Oh, whoops, didn't mean to do that. Channel group 1 mode active, no shut. Interface range G0 23 through 24 channel group 3 mode active interface PO. Alright, oh, whoops, I misnamed that. That's fine. PO1 switch port trunk allowed VLAN. It's locally significant. It doesn't matter. 5 10 15 20 switch port mode trunk interface PO3 switch port trunk allowed VLAN 5 10 15 20 switch port mode trunk, and we're done. So all our VLANs are created, are trunking, and let's go ahead and do show ether sum. Sweet. LACP has been successfully negotiated between switch 2 and switch 0 and switch 1 and switch 2. And then do show ether sum. And the same can be said between switch 0, switch 1, and switch 0, switch 2. So we know it's successful all around. The way I know that's successful is because if we look under the port channel column, we're going to have the list of the interfaces, and in parentheses they'll have some indicators, some flags. This one is a capital S, which means it's a layer 2 ether channel, and the capital U means it's in use. Do show interface trunk shows that everything is trunking between them. And there you go. That's ether channel for you. If I simply shut down a port on any of these, I could maintain a data transfer. And if, let's say I hit my NAS for big data, and I have something else that needs to communicate with another device over that trunk link, well, guess what? Not going to be a problem, because it's going to use another line, or it's going to load balance between the two. Anyway, I hope that helps, and have a good one.